Okay, so this is the first of three review videos on trigonometry, and the starting point for us is the unit circle. So I guess the name trigonometry here is a bit of a misnomer because trigonometry refers to triangles, and this is usually how you first learn trigonometry is in terms of angles in a right-angled triangle and relationships between the lengths of the three sides. But once you move on to the calculus point of view, when you're doing trigonometry, you're working with the unit circle, and the trig functions are going to be defined in terms of points on the unit circle. So let's start off by reminding you, well, what is the unit circle? Well, the unit circle is a circle of radius 1. It's centered at the origin. So it has this equation, x squared plus y squared equals 1. Just as a reminder, let me kind of sketch a few things out for you here. So let me draw Cartesian coordinate system, x, y. One of the things that you might recall is that if I have 2 points, say x1, oops. So let's say my 2 points are x1, y1, x2, y2, and I want to know the distance between them. I want to know what the length of that line segment is. The distance formula, which by the way is the distance formula comes straight from the Pythagorean theorem. The distance formula says that the distance between those 2 points is given by, well, I do the difference between the x coordinates squared, and I do the difference between the y coordinates squared, and I take the square root of that whole thing. Right? So when you're thinking about plotting points on the unit circle, well, we're centering at the origin. So one of our points is right here at the origin, 0, 0, and I choose some other point. Okay. X, y. And of course I can drop that down to here and I get the point x0. So I know that this length here is x. I know that this length here is y. And the distance I want from the origin, the radius of my circle, is given, well, Pythagorean theorem says that this distance is given by x squared plus y squared. And I want x squared plus y squared to equal 1, radius 1, and that's where the equation of our circle comes from. Now, let me get rid of this. We don't really need it. There we go. Get the points I missed. Let's draw that circle. So what does that circle look like if I draw it in? Well, it looks something like this. Alright. It's not a great circle, I admit it. My whiteboard circles are much better than my computer circles. Okay, so a few points of interest on the circle. When x is equal to 1, 1 squared is already 1, so y must be 0. The point 0, 1 up at the top is also on there. We've got the point minus 1, 0 over here, and down at the bottom we've got the point 0 and minus 1. Okay? And of course there are many other points on the unit circle, but we draw those for now. So that's the unit circle, and what we're interested in actually are understanding the coordinates of the other points on that unit circle. And what we want to do is we want to understand the coordinates of those points with relationship to a certain angle, that angle being this angle right here as measured from the positive x-axis. So we'll call that angle theta, is a popular choice for an angle. So the angle that is made by the radius here and the positive x-axis gives us a way, so that number theta, that angle, actually identifies every single point on the unit circle, right? If I know what my angle is, the angle tells me where to draw this hypotenuse, and that tells me where I am on the unit circle. So there's this connection between points on the unit circle and between angles, and this is what we're going to use to define our trig functions in the next video. One thing that I'll point out is that we're initially going to define trig functions as functions of this angle, and then eventually we're going to want to actually say, well, in fact, our trig functions should be functions of a real variable. All of the functions we deal with in calculus are functions of a real variable, so we want to make this identification between angles and real numbers. And one of the ways that we do that is to say, well, first of all, angles have to be in radians. They've got to be in radians, otherwise anything in calculus that has to do with trig completely falls apart. All the formulas are wrong. If you work in degrees, you got to work in radians. This turns out there's just no way around it. So if you kind of set things up so that angles are in radians, there's kind of a nice thing that happens. If you measure the kind of length, you cut off a piece of the circle, right? So you choose a particular angle, you take a couple of points that span that angle, and you cut off the piece of the circle that's highlighted there in red. Well, if you were to stretch that out and measure the length, it turns out that there's a formula for the length of that piece, and as long as you're working in radians, right? Because if you're not working in radians, then this formula is going to be wrong. You're going to have to adjust for the scale factor between degrees and radians. But in radians, arc length is simply given by the angle times the radius of the circle. Now, our radius is 1, and that means that the arc length and the angle are in fact the same value. One is measured in radians, the other is a real number, but this is what actually allows us to identify real numbers with angles, as long as our angles are measured in radians. And we'll make use of that in the next video when we define the sine and cosine functions.